So 13.1 goes over sequences and summation notation. We're going to focus on sequences first and look at these groups of numbers, which we call a sequence. These sequences can be represented by multiplication, addition, subtraction, division, meaning fractions multiplied by a number, all of that. So there is a pattern that's happening within these sequences. So you're going to either be given the pattern or have to find the pattern and find certain numbers within the sequence. So those numbers that you're finding are terms. So you'll find the term within the sequence. A sequence is just a function whose domain is the set of natural numbers. The terms in this sequence are the first term, the second term, the third term, or the nth term. Your a sub 1 is just considered the first term. A sub 2 is considered the second term. A sub n is the nth term. Okay, so the first part that we're going to look at, or the first example that we're going to look at, is finding the terms within the sequence. We're finding the first 5 terms and then the 100th term within the sequence. You may use your calculator with these. It will help you for some of them. For A, we're given A sub n is equal to 2n minus 1. So I'm going to rewrite my rule and then find the first term through the 5th term and then the 100th term. So if I find the first term, or A sub 1, I'm going to plug in 1 for n and just simplify. So that's going to give us 2 times 1 minus 1, which is 2 minus 1. That's 1. To find the second term, we're going to plug in 2 for n. So that's 2 times 2 minus 1. That's 4 minus 1, which is 3. To find the third term, or A sub 3, we're going to do 2 times 3 minus 1. So that's 6 minus 1, which is 5. For the fourth term, that's 2 times 4 minus 1, which is 8 minus 1 is 7. Then for the fifth term, that's 2 times 5 minus 1, which is 10 minus 1. That gives us 9. To find the 100th term, we're going to do 2 times 100 minus 1. That's 200 minus 1, which is 199. So to write the sequence, you can give 1, 3, 5, 7, 9, period, 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 199. So that just gives you, like I said, the sequence for this rule. For example, B, we have the rule C sub n is equal to n squared minus 1. So to find the first term, we're going to have 1 squared minus 1, which is 0. To find the second term, that's 2 squared minus 1, which is 3. To find the third term, that's 3 squared minus 1, which is 8. To find the fourth term, that's 4 squared minus 1, so 16 minus 1 is 15. To find the fifth term, that's 5 squared, which is 25, minus 1. So that's going to give us 24. And then for the 100th term, that's going to be 100 squared minus 1. So that's going to leave us with 9,999. So if we were to write the sequence, we would have 0, 3, 8, 15, 24, and then the 100th term would be the 9,999. For example, C, we have the rule T sub n is equal to n over n plus 1. So to find our first term, we're going to have 1 over 1 plus 1, which is 1/2. To find our second term, we're going to have 1 over 2 over 2 plus 1, which is 2/3. To find our third term, we're going to have 3 over 3 plus 1, which is 3/4. Our fourth term, we can use 4 over 4 plus 1, which is 4/5. And our fifth term, we're going to have 5 over 5 plus 1, which is 5/6. And then lastly, our 100th term is 100 over 100 plus 1, which is 100 over 101. So our sequence is going to be 1/2, 2/3, 3/4, 4/5, 5/6, and 100 over 101. For example D, we have the rule r sub n is equal to -1 to the power of n over 2 to the power of n. So if we find r sub 1, or our first power, we're going to have -1 to the first power over 2 to the first power, which is -1 over 2. For our second term, we're going to do -1 squared over 2 squared, which is just 1/4. For our third term, we have -1 cubed over 2 cubed, which is -1 over 8. For our fourth term, we have -1 to the fourth power over 2 to the fourth power. So that's going to give us 1 over 16. For our fifth term, we have -1 to the fifth power over 2 to the fifth power, which is -1 over 32. Lastly, for our 100th term, we're going to have -1 to the power of 100 over 2 to the power of 100. If you use your calculator to simplify this, the -1 to the power of 100, you should not need your calculator for. It's raised to an even power, so automatically it's going to become positive. So that's going to be +1 over 2 to the 2 to the 100th power. Your 2 to the 100th power is going to give you a number in your calculator. Most likely that's this 1.2676506 times 10 to the power of 30. You can leave it in this case as 2 to the power of 100 because that number that your calculator is giving you is not an accurate number. So for this case, leave it as the 1 over 2 to the power of 100. So your sequence for this one is going to be -1/2, 1/4, -1/8, 1 over 16, -1 over 32, ... 1 over 2 to the power of 100. For your next example, it's telling you to find the nth term of a sequence whose first several terms are given. For example A, you're given 1/2, 3/4, 5/6, and 7/8. You'll realize with this, your top numbers are all odd numbers. Your bottom numbers are all even numbers. In order to get an even number on the top, on the bottom, and an odd number on the top, you're going to have to multiply each of these terms by 2 and subtract 1 from it. Okay. For something like B, where you have -2, 4, -8, 16, -32, we realize that those signs differ from each term, so they're all opposites. In order to get from 2 to 4, you multiply it by 2. From 4 to 8, you multiply it by 2. From 8 to 16 is 2. From 16 to 32, you multiply by 2. So in that case, because they're negative and you're multiplying by 2, it's just -2 times n. Okay. Your next section goes over partial sums of a sequence. When you're working with partial sums, you are finding the first term, then finding the second term, finding the third term, finding the fourth term, and adding them all up. So you're going to have a partial sum, which means addition is going to be used. This just tells you that the first term is called the first partial sum, second term is the second partial sum, so on. With your first example, though, it tells you to find the first 4 partial sums and the nth partial sum of the sequence given. So for this one, you have 1 over 2 to the power of n. To find the first 4, you're going to find the first, the second, the third, and the fourth. To find the first, it's going to be 1 over 2 to the first power. So that's just 1/2. To find the second, it's going to be 1 over 2 to the second power. The third is going to be 1 over 2 to the third power. The fourth is going to be 1 over 2 to the fourth power. So that's going to be 1/4, 1/8, and 1 over 16. Your partial sum means that you are going to add all of these. So that means you're going to have 1/2 plus 1/4 plus 1/8 plus 1 over 16. Remember, with fractions, you need your least common multiple in order to, your least common denominator in order for you to add these. Least common denominator here is 16. So that 1/2 is going to turn into 8 over 16. The 1/4 becomes 4 over 16. The 1/8 becomes 2 over 16. And the 1 over 16 can stay 1 over 16. Add up all of your numerators. 8 plus 4 is 12, plus 2 is 14, plus 1 is 15 over 16. If we look at our next part, we're going to be looking at sigma notation. That sigma, or that Greek letter that you see there that looks kind of like that E, just means to find the sum. So when you're working with these, you're going to have a k is equal to, or a variable is equal to on the bottom, and that's going to be what you're starting at. So that's going to be the number of the term that you're starting at. The number on the top, that n, is going to be a number. That's going to be the number that you end with, so the term that you end with. So sometimes it'll be 1 on the bottom, 5 on top. That means 1, 2, 3, 4, and 5 terms are going to be found first. Then you're just adding them up. What's to the right of that sigma is going to tell you your rule in order to find each of your terms. So if we look at some examples, for our first one, we have this 5 on the top of our sigma. Let's do. So 5 is on top. You have k is equal to 1 on the bottom, and your rule is k squared. So you're going from 1, you're doing 2, 3, 4, and 5. So in order to find these, you're going to have your first term, your second term, your third term, your fourth term, and your fifth term. Your first term is just going to be 1 squared. Second term is going to be 2 squared. Third term, 3 squared. Fourth term, 4 squared. Fifth term, 5 squared. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. If we add all of these together, you have 25 plus 16 plus 9 plus 4 plus 1 gives us 55. For example B, we are starting with j is equal to 3. We're ending at 5, and our rule is 1 over j. So we're finding 3, 4, and 5. So if we find 3, 4, and 5, we're going to have for 3, 1 over 3. For 4 is going to be 1 over 4. And for 5, that's going to be 1 over 5. So we're going to add 1/3 plus 1/4 plus 1/5. Your least common multiple out of the 3, 4, and 5 is 60. So these are going to turn into 20 over 60. plus 15 over 60 plus 12 over 60. Add your 20, 15, and 12. That gives you 47 over 60. For example C, we are going to start at 5. Oops. K equals 5. We are ending at 10. And our rule is just K. So we're starting at 5. We're going 6, 7, 8, 9, and 10. If it's just K, that means that's the number of the term that you're finding. So 5 is going to be 5, 6 is going to be 6, 7 is 7, 8 is 8, 9 is 9, and 10 is 10. From here, add these all up. So 5 plus 6 plus 7 plus 8 plus 9 plus 10. This should give you 45 for your answer. For our last example, we have our sigma. Underneath it, we have I is equal to 1. On top, we have 6, and our rule is 2. So we're going 1, 2, 3, 4, 5, and 6. So I put down my numbers 1, 2, 3, 4, 5, and 6. All of these are going to be 2 for each of the terms because that's my only number, or that's my only term on my outside of my sigma, and there is no I attached to it. So they're all going to be 2s. From here, we add up all 6 2s. So 2 plus 2 plus 2 plus 2 plus 2 plus 2 gives us 12.